Hi everyone. I apologize for having to leave the limits section as video notes. However, hopefully they are helpful to you, and if you have any questions, remember that you can always go and ask Ms. Geiselman for assistance. So hopefully you had a chance to take a look at the worksheet titled What is a Limit? And what we're going to do now is kind of go through each of those questions in a little bit more in detail, and also go through a few more examples of finding the limit graphically from a function for a function. So first of all, on this worksheet, you have the function f of x, and it is a rational function. However, if you take a look at the function, we can simplify this. Our numerator is factorable, so it can become x plus 1. Sorry, x plus 1. And x minus 4 all over x plus 1. Now remember, thinking back when we were graphing rational functions, when you have binomial in your numerator and denominator that can cancel, that signifies that we are going to have a whole. So we're going to have a whole at the x value of -1. If you can think back also how to find the y value, once you simplify that, our f of x function becomes x minus 4. We can take this x value of -1, substitute it into this new function f of x, and calculate our output. So our output is actually going to be -5. So I would start off by always doing that, taking a look to see if there's any holes, because we want to think about what the graph of this is going to look like in order to identify limits. So the first question you have is, what is the domain of f of x? So remember, we had the function, we write it up here, x plus 1 over x plus 4. Oh, I'm sorry, that was x minus 4, right? Let me just get rid of that. Okay, so I'm sorry, it was x plus 1 and x minus 4 over x plus 1 before we simplified. So if you think about what is the domain here, the domain is x values that are greater than -1. That's coming from our domain. And after we simplified, we discovered that our function was then going to be f of x equals x minus 4. So what is that graph actually going to look like? Well, f of x being x minus 4 gives us a nice, pretty linear function. So it is going to be a line, but it is going to be a line with that hole like we had discussed at -1, -5. No other real characteristics about the graph that we should know at this point, but you should be able to identify that it is going to be a linear function with a hole, just by simplifying and taking a look at that function. So next we're asked to complete this table. So hopefully you were able to complete the table and identify the values that I have here in red, the -6, -5.25, -5.1, and -5.001. Basically what we were asked to do here is to evaluate the function at a series of x values. These x values are said to be approaching -1 from the left. So after identifying those output or y values, we can basically say that as you near the x value of -1 from the left-hand side, the left-hand limit of -1 is going to approach a particular value. If you take a look at these numbers, what value are we getting closer and closer to? We're getting closer and closer to -5. So the way we write that is the limit as x approaches the value of -1 from the left. That's what this little minus sign here is, of the function f of x is going to be -5. Okay. Now let's take a look at other values. This time we're approaching -1 from the right. And again, I got these values of -3, -4.75, -4.9, and -4.999. So again, as we get these y values we are going to notice that the right-hand limit of -1 is going to start to approach a value of -5. So again, the way we write that is the limit as x approaches -1 from the right, which is what that plus sign is telling us now, of the function f of x is going to be -5. So we identified the limit as x approaches -1 from the right and the left for this particular function by just taking a look at some values for x that are coming from the left-hand side and values coming from the right-hand side. Now if we take a look at the graph, I've already graphed this in here for you. I basically just, using that f of x ends up being x minus 4, I just basically plotted a couple of points, graphed if they're down here at -4, it has a +1 slope and so on. I added in that hole. Now if you think about what we just discussed with limits, the limit as x approaches -1 from the left. So here I am from the left. I'm coming in from the left. As it approaches -1, sorry, I didn't mean to do that on top of it. As it approaches -1, the y value is going to be -5. And if we take a look at the right-hand side, the limit as x approaches -1 from the right-hand side of the function f of x, as we're coming in from the right, as we get to the value of x equals -1 right here, again, we're going to see a y value of -5. So that's basically all we're doing here. It is relatively simple when you're looking at it graphically. So if you flip over to the other side, one important thing we need to remember here is that when the left and the right hand limits both exist and they are equal values, then in general we can say the limit as x approaches -1 does exist. So we can now drop off that plus or minus at the end. So as x approaches -1 of f of x, the limit will exist because in our example, both from the right and from the left, we had a limit of -5. So yes, our limit is going to exist and that limit is going to be -5. So only if the left and the right both have the same value will the limit as x approaches -1 exist. So in general, if we're trying to write a few sentences describing what a limit is, I have done so here. The limit of a function as x approaches c is the value of the function that it appears the function is getting closer to. That kind of sounds a little bit confusing, but it is going to get easier as we do more examples. The limit of the function as x approaches c does not have to equal f of c. So in this particular problem, we were looking at the limit as x approaches -1, and it just so happened that when we plugged in -1, we got -5 as an output, and that -5 ended up being our limit. That's not always going to be the case. Now, there are a couple of examples for number 10, but I actually only wanted you to do A. So if we think about A, and we think about the limit as x approaches 2. So what that means is we're going to evaluate both parts of this piecewise function at the value of 2. So we need to think about the limit as x approaches 2 from the left of this function g of x. And then we need to think about the limit as x approaches as x approaches +2 from the right of this function. So if you take a look at your piecewise, from the left would be this top one, because this top one is saying all values that are less than 2. So that means it's coming in this way, coming in across to 2. And then the bottom function here is when it's approaching from the right, because these are all values that are going to be larger than 2 on this side. So all we're doing here is we're evaluating at 2. If we plug in 2 for this left-hand piecewise, when we plug in 2, what is our output going to be? And when we plug in 2, we're actually going to get an output of 2. Easy enough. Now, when I do the limit as it approaches from the right, if I plug in 2, my output is actually going to be 5. Since they are not the same, samey. And since they're not the same, that's an A there. What we can say here is that the limit as x approaches 2 of the function g of x does not exist. So we write dna. Let's try and graph this real quick too. If you can think back to graphing piecewise functions. So when we're graphing from the left-hand side, we still want to know what the value of the function is when x is 2. We're just going to have an open hole there because it is going to be just less than 2. So when I plugged in 2, I got an output of 2. So I'm going to go over here, 2, 2. I'm just going to have an open circle. And then plug in other values. I'm going to plug in 0 because that's an easy one. 0 is going to give me 3. And I have another value over here. So our left-hand piecewise, sorry, my line is so shaky, is going to look something like this. The right side of this piecewise function, if we plug in 2, we said that the value is going to be 5. And it's actually going to be inclusive, so we're going to close that circle. And then up 3 over 1, here's another point up here. So here's my right-hand side of my piecewise. So if you take a look at this, the limit as I approached the value of 2 from the left is all the way down here at a y value of 2. But the limit as I approach from the right is up here at a y value of 5. So since they are not the same, the limit does not exist. Okay, I'm going to throw a couple more examples up here just for you to take a look at before you do some on your own. All right, this one says the limit as x approaches positive 1 from the left. So as I'm coming up from the left, as it approaches 1, it's going to be at a y value of 1. Now when I approach it from the right, when I'm approaching the x value of 1 from the right, the y value is 2. Since those two are not the same, when I do the limit as x approaches 1 in general, that limit does not exist. There is a big difference between talking about limit and just the value of a function. So if I'm asking you what is f of 1, I'm literally asking you when the x value is 1, what is the y value? So you're basically just looking at your open or closed circles, or where what the y value is when you have a closed circle at x equals 1. So I'm up here at 2. The y value when x equals 1 is 2. Let's try another one. Again, limit as x approaches 1 from the left. So as you're coming in from the left, here's our x value of 1. We're going to approximate that to be a negative 1, even though it's slightly below. Let's just assume that's a negative 1. Now when I'm looking at from the right-hand side, as I'm coming in from the right to get to my x value of 1, I'm up here at positive 1. Again, they are different, therefore the limit does not exist. However, if I look at f of 1, the value of f of 1 does exist. At f of 1 is this closed circle right here. So f of 1 has a y value of 0. Notice the difference there with the two of them. Okay, another one real quick. As x approaches 1 from the left, so as I'm coming up from the left, as it approaches 1, it has a value of 1. As I'm coming in from the right and approaching 1, it also has a value of 1. Therefore, the limit as x approaches 1 is equal to 1. F of 1 is just wherever the closed circle is here, so f of 1 is going to equal 0. How about the limit as x approaches negative infinity? So as my x values, think about this, you're going this way. As my x values get smaller and smaller and smaller, what's happening to my y value? Well, as this line continues, my y value is going to continue to get smaller and smaller. So the limit as x approaches negative infinity is equal to negative infinity. Same thing with our limit for as x approaches positive infinity. As we continue to go to the right-hand side, as our x's get larger, our y value is going to continue to increase as well. So our y value is going to approach infinity as well. Let's try and get one more example in. So this last one here, as x approaches 3 from the left, here's our 3 value coming in from the left. That value from the left is actually going to be infinity. Our value from the right is continuing to go up there as well. It's also going to be infinity. So therefore, the limit as x approaches 3 is infinity.